Here we are going to be taking a look at these things called cube roots. Now they're very similar to square roots. The only difference is now we have a cube which is actually made up of 6 squares. So here's the square, here's the square, just like on the dice that you used to play Monopoly, right? That's a cube. So cubes are made up of 6 squares for a 3-dimensional shape. Also, the volume of a cube is the length of an edge multiplied by itself 3 times, and it looks like this. Okay, write that in your notes. The volume is edge times edge times edge. In this example down here, the edge length was 2, 2, and 2. Okay? Now we can also rewrite when we multiply things by itself twice, right? When we did side by side, that was area. So area was side times side. We said that that was side squared because that represented the area of a square. Now we're doing it with a volume. So edge times edge, or side times side times side, but edge, this is really more accurately on a cube, those are edges. Edge times edge times edge is e to the 3rd, or e cubed. So we're going to be doing the same thing. If we know what the area of a square, so let's say this area was 7, we can easily find the side length by taking the square root of the area. So the side length was the square root of 7 for an area of 7. Now, let's say we have a cube and we know its volume. Okay, so if we know the volume of the cube is 108, let's say, that would be units cubed. Okay, what this is saying right in here is you can easily find the edge length, right? Or the side length, or whatever you want to call it, but for cubes it's more accurately edge length. You can find the edge length just by taking the square root of the volume. Okay, so the edge length would be the square root of 108 units, whatever that might be. You can plug it in a calculator, but it's unnecessary. We can just keep it as a square root of 108. So you can see it's very much the same for cubes as it is for squares. Just add another dimension. Instead of length and width, you also have depth. For a square, it was length and width, but now you have this 3rd dimension, depth. Okay, so you have to know the terminology. When you're cubed something, it's taking it to the 3rd, right? So 2 times 2 times 2, that's 2 cubed. That's 8. Now, if you're doing the inverse of that, so instead of taking 2 to the 3rd, you're figuring out what number times itself 3 times will give me 8. That's the cubed root of 8. And this is what the cubed root of 8 looks like. So write that in your notes. This is the cubed root. And the question it's asking is, what number times itself 3 times will give me 8? If we generalize that a little bit, we can do it for any number. So let's say the cube root of n, as they have down here, right? That is the cubed root of n. So it's asking the question, what number times itself 3 times will give me whatever this n value is? Okay, so there, just like there are the list of perfect squares, there's also a list of perfect cubes. For example, like 1 cubed is 1 times 1 times 1, that's 1. 2 cubed is 2 times 2 times 2, that's 8. 3 cubed is 3 times 3 times 3, that's 27. Go ahead and make a list all the way up to 10. Pause the video, make your list up to 10, and then come back and check them. If you need to use a calculator, that's fine, but make your perfect cubed list all the way up to 10. Have them in your notes. So here are your first 10 perfect cubes. Be familiar with these values, because if it asks you for the cube root, for example, of 729, your answer is just 9. Because the cubed root of 729 says what number times itself 3 times will give me 729? The answer is 9. Write these in your notes and be familiar with them. Go ahead and try part A on your own, finding the edge lengths of the different cubes with those volumes, 127, 64, and 125, and finding the values of the cube root of 1, cube root of 27, 64, and 125. Pause the video, do numbers 1 and 2 on your own, and then come back and see how you did. Okay, so let's see how we did on these. If it has a volume of 1, the side length or edge length would be 1. Volume of 27, right? So what you're trying to do is you're trying to figure out, okay, if this has a volume of 27, then my edge length, which I'm taking times itself 3 times, it will give me what? And that was 3. And then if you have a volume of 64, that would have given you edge lengths of 4. And 125 edge lengths of 25. Number 2, you see you get the same answers, and purposely did this because in order to find the edge lengths, you're just taking the cubed root of each one of those. So you get 1, 3, 4, and 5 for this one as well. On part B, part 1 says, what is the volume of a cube with an edge length of 5 units? What is the volume of a cube with edge length of 2.5? Go ahead and answer part 1. Pause the video and then come back and see how you did. All right, so if the volume of a cube is what we're trying to find, and it has an edge length of 5, well, the volume is 5 to the third, and so that is going to be 125 units cubed. Volume is always cubed. If it has an edge length of 2.5, then the volume is going to be 2.5 cubed. I'm not really sure what that is without plugging it into a calculator, but I'm just going to keep it 2.5 cubed units cubed. So if you're taking a quiz or a test and you're not allowed to use your calculator, please just leave it as this, right? Because this is an actual number. It's just not simplified, but that's fine because what we're learning here is about volume, cube roots, not actually finding 2.5 times 2.5 times 2.5, but the idea that the volume is 2.5 to the third. Okay, so just leave it like that. That's completely fine, but definitely label it units cubed. Go ahead and try numbers 2 and 3 on your own, just figuring out what goes into those missing places or figuring out what X is. Okay, so for the first one, the cube root of what number is 5? The answer is 125 there. Cube root of 125. And then the cube root of what number will give me 2.5? Again, we answered all of these up here. If you multiply 2.5 out, that's fine, but I'm just going to put 2.5 cubed. You notice up here, you could have 5 cubed as your answer, and I would be completely fine with that. Okay, because 5 cubed and 125 are the same thing. Let's jump down to number 3. X cubed is equal to 27. So what number times itself 3 times will give me 27? Remember, that's the same as asking what's the cube root of 27, and X is 3. On B, now it's a negative 27. So what number times itself 3 times will give me 27? Well, I know 3 times 3 times 3, but to get a negative 27, those have to be negative 3s. And so your answer is X is equal to negative 3. Part C, this could be a little bit tricky, but again, if you're asking what number times itself will give me 1/8, that's like taking the square root of 1 over 8. So the square root of 1, that's 1, and the square root of 8, that's 2. So X has to be equal to 1/2. All right, so now here, this is saying what number if I take what a number times itself 3 times, which is 27, okay, these are asking the same questions. What will I get if I multiply 27 to itself 3 times? That is a large number. So if you want to, you can just say x was 27 to the third, and that would be completely fine, because the cube root of 27 to the third, if you take the cube root of 27 to the third, all right, the cool part is these are inverses, so they will cancel each other out, and you will be left with then just 27. So over here, the cube root of what number gives you negative 27? Well, it's just going to be negative 27 cubed is our x value there. And then on part F, this was, again, up here is 1/2. So if you want a negative 1/8, it's going to be negative 1/2 on that one. And part 4 says explain what each positive value of x might represent in terms of volume and length. Right, so some of these would be volume, like this would be volume. This would have been volume, but if that's positive, that was volume. But also this would represent the lengths. Okay, so depending on if you're finding x or not, if you're finding the cubed roots of x, that was the length. And if you're not, that would be the volume. All right, so part C. Between which two consecutive whole numbers does the cubed root of 10 lie? Go ahead and answer part C, 1 through 5. And I'll give you a hint. You're going to be using these perfect cubes right here to answer some of them. Pause the video and answer numbers 1 through 5 on part C. Okay, so for number 1, square root of 10, right? It's going to fall between here and here. All right, so 10 falls between here and here. And it's actually really close to 8. So the square root of 10 is going to be close to 2. All right, so to answer that question, part 1, between which two consecutive numbers does that lie? It lies between 2 and 3. Part 2, which whole number from part 1 is it closer to? Well, it's closer to 8, or it's closer to actually 2 is the whole number that you're looking for, right? So it's going to be closer to 2 than it is to 3. And then number 3 says, without using a calculator, estimate the value to 1 decimal place. All right, so if we estimate it to 1 decimal place, if I had to estimate the square root of 10 to 1 decimal place, I'd say maybe approximately 2.1. Or 2.2, right? Anywhere 2.1, 2.2, 2.3. If you had any of those, I would accept those on a quiz, but it's extremely close to the square root of 8, which is exactly 2. So it should be something close to 2. Number 4 says, without using a calculator, can you get an even closer estimate? Well, listen, that's just saying add another decimal. So I was somewhere between 2.1 and 2.2. So I'm going to say this is 2.17. Okay, that's just my guesstimate. Whereas the actual answer is something like 2.154. So this is a really close answer, right? Just guesstimate by understanding square roots or cube roots and how they work. So that was number 4, right? That was my guess. And number 5, 3 students find the edge length. So let's look at it. 3 students find the edge length for a cube with a volume of 10 cubic feet. All right, so that's the volume of a cube. How might each student have arrived at their answer? Well, right off the bat, right, if you have a volume of 10 cubic feet, then you know the edge length is square root of 10 feet. Now, we estimated that to be approximately 2.17. Okay? So, right off the bat, you know Kevin cheated and used a calculator because the exact answer is 2.1544. It keeps going. right? So Kevin used a calculator. Josie, however, this middle person right here, estimated like what we did. And then Nick was probably like, hey, guy, it's somewhere between 2.1 and 2.2. I'm not really sure, so I'm going to say 2.15. Right, so there's like somewhere in the middle, and that's why they put 2.15, because they weren't sure 2.1 or 2.2, so they went in the middle there. Okay, so that's what I would say. How did they each arrive at their answer? Kevin definitely used a calculator, and Nick was unsure if it's 2.1 or 2.2, so he went in between. All right, go ahead and answer part D, 1 and 2. And then come back to the video to see how you did. So looking at which is greater. Now, we don't want you to use calculator. It says right at the top, use your calculator only when instructed to use so. And on part D, you were not instructed to do so. All right, so the square root of 8, we can look at that. If you think about your perfect squares, the square root of 8 is somewhere between, well, you would have the square root of 9 and the square root of 4, which is between 2 and 3. And it's actually really close to this. So if I had to estimate, the square root of 8 is about 2.8. Okay? Whereas the cube root of 8 is exactly 2. So the square root of 8 is bigger. And it's the square root is always going to be bigger if you're comparing the same number, because it's just asking what number times itself once or twice, like 2 times 2, versus what number times itself 3 times. So it's splitting it again if you're taking the cube root versus just twice. And so that answers part 2. This one is always going to be greater. And make sure you explain. You can show what I did over at the right. That's completely fine. That's entirely up to you. Okay, that is it for 2.4 cube roots.